Hello, hello, hello. Mic test.
Oh yeah, welcome back. Hope everyone has a good lunch. So this is the afternoon track for web and mobile, right? And our first speaker will be from Mr. Herman Park from R&D principal R&D engineer from Notifiles, and his topic will be universal motion graphics across all platforms, unleashing creativity with Tor VG. It's a 25-minute talk with Q&A. Right, so let's hear from Mr. Park.
Okay, hello everyone. My name is Hermet. Welcome to my session. I currently work at Notifiles, which is a startup specializing in motion graphics and design. And I'm the creator of a Thorough Vector Graphics open source project, which is about building high quality vector graphics engine. So in today's talk, I would like to give you an overview of motion graphics with a trending Lorry animation and Thorough Vector Graphics project, exploring what they are and how we can incorporate them into our modern application visuals. Time is short, so let's jump quickly, explore them together. So first of all, what is motion graphics? Simply put, you can think of it just like moving visual content, much like animations. And today, motion graphics is very common, especially in design. It actually helps to deliver content more clearly and make it easier for users to understand the content, right? And engineering perspective, vector graphics is the foundation of modern motion graphics today. And for those who are less familiar with them, please let me walk you through briefly. As you might know, like bitmap images, like a JPEG, PNG, they actually store the fully rendered image pixel by pixel. But in contrast, the vector graphics only stores the mathematical formulas, and that makes the vector graphics more ideal for a wide range of applications today. One of the greatest advantages of vector graphics is that it's scalability. Even though the data size is quite small and compact, it can be displayed on any size of screen, any resolutions, without losing quality. And another key advantage of vector graphics is that it's flexibility. Since the shapes are defined by mathematical formulas, developers can easily adjust the parameter values, to modify the visuals in real time, making vector graphics more powerful for those moving visual content. And historically, SVG was the most widely used vector graphics format in the industry before. But in the past few years, Lorry has been emerged as the go-to solution for the vector animated content. And since the motion graphics has been trendy, these days Lorry is really popular and used everywhere. There are several well-known vector graphic projects you can consider when you're building your own custom vector graphic solution for your project. And one of the most popular one is the Skia from Google. Skia actually has the extensive rendering features, as well as its rendering performance is well optimized with the hardware accelerations. But those decent vector graphics engines today actually quite complicated, and those complexity could be challenging when it works on some resource constrained devices. So that is one of the reasons why we started ThoroughVG project, aiming to strike the balance among the portability, functionality, performance with the modern style interfaces. So we'll take a look at the project in the next page. Before that, let's move on to Lorry. Lorry is an open standard, efficient, scalable, and cross-platform vector graphic format. Originally, it's designed by a developer. The name is Hanan Torres. After that, it has been further developed by Lorry animation community, which is a working group. Today, actually, they continue to refine and develop the Lorry specification. Today, we can say Lorry is industry standard because it's so widely used. Many projects actually rely on Lorry asset for their visual effect and the motion graphics UX, And even the Linux Foundation officially supports the Lorry animation project. And personally, I also prefer to use Lorry because often the Lorry, even though Lori was designed for animation live from the get-go, often it results in a smaller size compared to SVG, while in making efficient and compact runtime performance. But most of all, designers love to use Lori. It's quite functional and easy to use, works well across different platforms, giving designers more freedom to express their creativity. So, yeah. Then you might wonder how we can apply Lori with our project, right? There are some comparable design editors for Lori animation, and for example, Adobe After Effects and Lori Creator from Lori Files. Especially Lori Creator is born to Lori, which means that the design editor actually have been designed only for the Lori animation. So it's quite well aligned with the Lori animation features and its specification. It's quite a compact and web-based application and free for everyone. So if you are looking for some certain design editor for Lori animation, you can consider the Lori Creator as one of the options. Also, TurboG is the one of the most key vector graphics engine that supports the Lori animation features. Also, I would like to introduce one more project, .Lori. .Lori is kind of like an advanced version of Lori animation. So we'll take a look at this project as well next soon. Thorough Vector Graphics is a fully open source project being developed by more than 7 active contributors these days. Actually, it began in 2020. It's almost 5 years old. And it's on track to release the official 1.0. But most of all, this is the vector graphics engine, but it differs from traditional vector graphics libraries such as the Skia. While TurboG supports the most essential vector drawing primitives such as the line drawing, circle drawing, fill color, something like that, it also provides a retained-based rendering mode with the manageable drawing object and the scene graph, which means that TurboG actually handles much of a complex drawing process under the behind of applications. Apps only need to manage the drawing object and update their properties as needed. Then TurboG instead TurboG TurboG rendered the image instead of applications appropriately. So that is a good key advantage of TurboG. And another key feature of TurboG is that it supports both SVG Lori features out of the box, which are industry standard vector graphics format most today. So applications don't need extra libraries or plugins for those feature support. TurboG instead implemented those features more efficiently and making TurboG more easy to use. Another big advantage is that it's a portability. TurboG can run on any devices or systems without external dependencies. Even its binary size is super small. For example, if you build a TurboG with the only with the essential drawing primitives with the software rendering engine, it just takes about the 150 kilobyte. It's quite making TurboG ideal for small IoT devices. Even Lori support enabled, the build stays less than 400 kilobyte. Still, it's extremely compact. And based on these characteristics, TurboG is actually web-friendly through the WebAssembly mechanism. So if you're a front-end developer and if you're looking for some custom graphics engine for your project, then probably TurboG could be one of the options you can consider. About performance, it's a software rendering is both lightweight and fairly efficient. TurboG also supports the hardware acceleration, such as the Web GPU, WebGL, OpenGL, something like that. To the best of my knowledge, Web GPU is something new. Only few vector graphics library currently support the Web GPU rendering engine, and TurboG is ahead of the curve, specifically in the web ecosystem. Lastly, TurboG has been designed with the modular architecture, enabling integration flexible. Officially, it relies on a Imagine build system and lets you easily toggle the Thoroughbridge features through the build options. This means that you can just enable only the features your application need, and that actually keep the binary size small and reduce the both integration complexity and the maintenance overhead. So until now, Thoroughbridge has been integrated with some certain open source project, for example, Tizen platform, Gada game engine, LVGL GUI frameworks. Thoroughbridge serves as the vector graphics engine there. Also, it has integrated with some certain products such as the graphical editor and indie games or visual effect of the application or some design editor like a Canva, something like that. Until now, Thoroughbridge has implemented WebGPU as one of the random backend engine. You know, WebGPU provides a next generation API similar to Vulkan, leveraging the computer shader and offers low overhead modern GPU access for more aggressive optimization strategy and broad application. Furthermore, unlike WebGL, WebGPU actually has no instance limitation, enabling multiple Thoroughbridges to run simultaneously. This means that you can launch Thoroughbridge engines more than as the Lori player and Lori animation player, more than 50, more than 100 at the same time on the same screen. Actually, in case of WebGL, it has an instance limitation about 16 number in general, so you can. It's not quite compatible with a certain runtime engine like Thoroughbridge. For example, Scotty is the Skia-based Lori animation player. It also has that instance limitation with the WebGL, so you cannot launch more than 16 Lori animations at the same time. But anyway, with the WebGPU, it's more promising, you know, since it resolved this kind of a technical limitation, and it actually allows us to more, you know, various integration strategies. Additionally, WebGPU helps to enhance the portability by abstracting the underlying systems graphics layer. As you might know, there are some certain hardware accelerations, such as the Metal, DirectX, and Vulkan. Thoroughbridge really don't depend on those hardware accelerations directly. Instead, it just look up the, you know, WebGPU layer. WebGPU redirect the hardware accelerations which are available on a current system. Yeah. So all in all, Thoroughbridge can run on any devices, regardless of the installed graphics layer, and you can just launch the Thoroughbridge with the WebGPU or WebGL or OpenGL or software rendering engine. So applications actually need to pick up the right render backend engine based on the current system environment and some, you know, GPU capabilities. And lastly, Thoroughbridge currently supports the most of vector rendering features within each spec on top of WebGPU. And you know, WebGPU actually is also under the development. So we actually try to align with the WebGPU project to bring the more qualified rendering engine as the WebGPU update progress further down the line. Another special feature of Thoroughbridge is that it's a built-in threading and task scheduler, which enables the fine-grained parallel processing to boost the scene building and the rendering performance. For example, if you enable this feature with the number of 4 threads, you might be able to gain the twice faster performance. But unfortunately, this is only available on some system which allows the thread. And in case of web environment, they actually has some thread security constraints, which is a little bit problematic with the task scheduler of the Thoroughbridge. So, but anyway, you can take a full advantage of this feature on a native or embedded systems where threads are available. Also, if you are a front-end developer, you might want to explore the web workers to parallelize some certain runtime engines like a Thoroughbridge. Practically, .load player in the next we'll check that actually handle over this web worker optimization with the Thoroughbridge for better performance. So if you're just looking for loading animation support for your web application, then that loading player might be a better choice rather than direct Thoroughbridge integration. Today, Thoroughbridge offers one of the most comprehensive and comparable loading animation runtimes available today. According to our metrics, Thoroughbridge supports the nearly 100% official loading specification 1.0. It's quite qualified as the loading animation runtime engine. And thanks to this strong comparability, Thoroughbridge guarantees the consistent behavior and the rendering performance across all platforms. And one of the most common issues with load is that, often its rendering result can be different across platforms due to variations in feature support among the different loading runtimes. For example, there are some loading web, loading Android, loading iOS. Those loading libraries actually have been designed and developed for different platforms. Their implementation method and the feature coverage could vary that lead to the differences in loading rendering result. And this inconsistency could be problematic for applications because we actually expect the identical rendering result across all supported platforms. And Thoroughbridge naturally resolves this issue by providing uniform playback experience. Since its portability is great, you can just integrate the same version of Thoroughbridge engine with your various application packages for each target, so that you can ensure the consistent loading animation result. Also, beyond the default plain loading animation support, Thoroughbridge also supports the most advanced loading features, such as the slam marker expressions. Those actually allows the runtime dynamic property change, state-based animation, and high-level control for user interactive animations. Basically, Thoroughbridge utilized the named segment feature of LORI, which is also known as markers, to support the state-based animation. As shown in the figure on the right, there one single animation has the three named segments, in this case, rectangle, circle, star. So in this case, this animation has the three named segments as a state. The point here is that makes the Thoroughbridge special is actually Thoroughbridge provide a function that interpolate two arbitrary frames which are not consecutive, which means that, for example, you can see in the demo on the right side, stereo tuning, there is one character is slowly learning and suddenly speeding up. So in this case, this animation has two states. One is a slow running and fast running. Even though the transition happens at any certain frame number, Thoroughbridge ensures the smooth transition by interpolating two different stereo scene information interpolation, So applications can bring this kind of a more smooth and seamless state-based animation playback. Another notable feature support is that user interaction. Thoroughbridge provides engine-level heat detection support, enabling applications to figure out which element in a loading scene have been selected or not. With this logic, actually, we can create responsible animations based on user input. And one demo at the bottom, as you can see, a heat detection on the right side at the bottom. That animation is also just one single animation, loading animation, but applications can figure out which button have been selected or not, so they can bring some more responsive or flexible animations based on the user's scenario. And lastly, Thoroughbridge supports the loading expressions. Loading expressions is lightweight and JavaScript-like scripting method, which allows to add the small-scale logic to specific parts of a loading animation. As you can see, some code snip at the bottom, expressions logic. We can actually write down that kind of a small logic. In this case, it's about the bouncing effect of the windmill. We can write down that kind of small logic and attach the logic to the specific part of the loading animation at runtime so that we can bring some animation variations. And another example is that controllable animation logic in the middle of the right side at the bottom, you can see the spinboard animation. So in this case, that animation is also one single loading animation, but it actually has the two parts. One is the finger and the spinboard. Through the expressions, we can actually modify some loading animation properties real time, so we can bring that kind of change the finger's position as well as we can change some rotation values of the spinboard at runtime. So all in all, with the expressions, designers or developers can add simple logic to loading animation at the design level, while also giving application opportunity to change the loading element parameter values with the Thorough, making them more dynamic and responsive to user input. One more thing, expressions can be also applied to impulse constraint. For example, you can see the most right side at the bottom, impulse constraint. There's one loading animation demo, and actually user drags the moving balloons and change their position, but the balloons never go outside a certain area. So in this case, actually, through the expressions, we can prevent unintended design deviations by addressing some range condition and exception handling, so that we can make the balloons always remains within a specific designated area. So this kind of impulse constraint could be easily achieved with the expression logic as well. So all in all, Thorough is the only library that supports state tuning and expressions. Most other loading animation libraries do not offer those features today. And lastly, let me introduce .load project. .load is an extended version of original loading format to enhance the loading's capabilities by providing advanced feature set. And one of the benefits of .load is the multiple animation support. Within a single .load file, we can attach the multiple load animation data, as well as we can bundle some additional assets, such as the image, sound, theme, to share them among the multiple animations. So, yeah, but it's not, .load is not just about collection of the multiple assets and multiple animations, but it's more like the compressed data structure containing all the data and zip together. Basically, .load file data size can be significantly reduced through the zip compression mechanism, so that we can actually improve the data transfer speed over the network, or maybe reduce the application package size, or maybe we can improve the application loading performance by reducing the memory bandwidth overhead. Even though one single animation, we can reduce the file size as well. For example, you can see some flying animation at the bottom. The size has been reduced by up to 70%. So it's really worth to try the .load format instead of the original JSON load file. And additionally, .load is supported advanced features such as the state machine theming interactivity on top of Thorough engine. But we actually explored those advanced features in the previous pages, so let's just skip the details. But the point here is, we actually we can with the .load file we can achieve those advanced features in a more structured and more efficient way with the .load player. To use the .load format in our applications, we can actually leverage the .load player, which provide some kind of the various platform integrations through each dedicated package, dedicated packages such as the Dalori Android, Dalori iOS, and Dalori Web, something like that. And since the Dalori player is built on Thoroughbridge engine, it of course guarantees the consistent rendering quality across all supported platforms. Also, it integrated some animation loop and the event system of the target platform. So applications actually don't need to be bothered by those complicated stuff. Only application can easily use the Dalori player as like, the just simple UI controller. And lastly, Dalori player is also open source and actively evolving. You can use the editor like Lori Creator to design and implement those Dalori advanced features for your application UX. So if you are interested in enhancing application UX with the micro interaction style, then probably Dalori might be an interesting project for you. Please check the Dalori site for the details. Thank you.
Yep. Thank you. Thank you, Mr. Hamed. Yes, so the perfect time is up, so we won't have time for Q&A, but please feel free to engage Mr. Park. He'll be still around. Yeah, so we'll get the second speaker set up. Yeah, so let's thank Mr. Park. Yeah.
I don't know if that will work on that. Hello. Hello, everybody. This is my first presentation ever at a conference.
Okay, cool.
Definitely nervous.
Okay, welcome to the Web and Mobile Track, our second talk. The speaker is Mr. Chris Bowart. He's a full stack developer, and his topic today, try Drupal or why Drupal, is also another 25-minute talk. So people will be at the back.
Okay, no problem. Hello, welcome everybody. My name's Chris Bovard, and I'm from Western Canada. I've been working with Drupal since 2007. Specifically, I have a background in back-end development, different languages, different stresses. I do enjoy working with Drupal, but in recent years, it has gotten complicated and lost market share to WordPress, which I'll get into. Has anybody here ever used Drupal or heard of Drupal? had problems with Drupal? Pardon? Yeah. Okay. Again, okay. Hello. Let's see. As I've been to other conferences, it always bugged me when I had to like type in URLs. So this is who I am. If you want to stalk me, if you have Drupal questions, I'll do my best to help. Yeah. Cool. Okay. Okay. Why would you use Drupal today? What would be the point if only one person in here has used it and another person's heard of it? That's basically was the biggest question I had when I wanted to do this presentation. I'm actually asking myself why I use it sometimes. In this modern web world, why not choose one of the big no-code solutions, or use another solution, or build your own custom thing? These are the other solutions that require no code, easy to use. Small businesses can spin stuff up quickly, get them out the door. You know, doesn't cost a ton of money in hosting. Well, sometimes Shopify does if you want to start doing a lot of transactions. Excuse me. So let's get into this. So what I do have clients that use Shopify recently. They moved from WordPress to Shopify. The reason why, they're a small business climbing shop in my hometown, and you know, they can't afford a massive e-commerce system like Magento. Drupal commerce is a beast. I have experience with that. You know, it doesn't really, Drupal doesn't fit the solution for a lot of small businesses anywhere. So I suggested they go to Shopify, get rid of their WordPress site, but they're having problems, which means they want to be able to blog, and they can't update their content, so their SEO ranking is going to go down. So it's proprietary. They're not happy. I don't know what to say to them, you know? Okay, let's go to the next slide. The biggest question. Why not just use WordPress for your website? I actually do have WordPress clients. I do not like working on their sites. It's a mess. I find it's a mess, you know. You need a plugin that does an XML site map, which one you're going to download, which one you're going to install, who wrote the code, where is it coming from, you know. Recent events with the WordPress drama, my take on it is the owner of WordPress is not happy that people are using his name and he's not making money, and all the code is spread across the internet, you know. When I took on these WordPress clients, it actually pays pretty well, and the owner of the company loves to go and start a WordPress. He likes to buy a domain, he likes to point it and click a button and install WordPress. But when I've gone into his array of 20 travel sites, I'm starting to notice the same thing over and over with the plugins. He's got the Yoast plugin. He's got a image, well, I installed a free image converter for WebP, and I started to notice all these different plugins. Even the backup plugin he pays a subscription for. So, excuse me, I'm a little rattled. Too much coffee. How much money a month is he paying? So we actually turned off one of these websites, and I messaged him and said, you know, did you know that you're not using this website? Are you still paying subscription fees for these plugins? And he's like, well, I am. So he saved him a little bit of money there. Would he go to Drupal? Probably not, because he likes to click install WordPress. Okay. Oh, we're getting deep. Why not a headless site using contentful, strappy sanity for your website? Well, let's see what the next slides say. Well, I took a year off work and I started to learn a lot of new things because I was stuck in this Drupal sphere and knowing what I call the one-trick pony of that and Magento. I don't put that I know Magento on my LinkedIn profile because I would never want to work on Magento again. But I saw companies that I did work for in the past, like going back almost 20 years, move from Drupal to WordPress to Contentful and Sanity. And one of their lead developers was like, oh, you gotta get into this Sanity, and we can plug it into a Shopify, and we have this headless front end that we built in Vue or Next.js or whatever tech stack they used. And then so I was like, okay, yeah, this sounds cool. So I started looking at it, and I'm like, wait a minute. The code is on Sanity and Contentful. It's proprietary. So you're paying subscriptions again, so you'll never actually own the code. So at some point, what happens if you want to get your data out? Do they have an export to Excel or CSV? Can you get your images? Who knows? Would they charge you for it? So I kind of dived into Strappy.js, and it was pretty cool, you know, I liked it. It was kind of neat, you know. But I found when I started to get really deep into the content types or entities, kind of doing relationships, I had a hard time. And it didn't kind of quite do what I wanted it to do, so I ended up coming back to Drupal. So, what is Drupal? This is what Drupal is. Drupal is a powerful open source content management system. You know, I'm not going to read through it, but basically this is, it's based on Symfony. In the background, you're using Composer, PHP package manager, which is similar to Node package manager, but a little different. It is open source, so everything's online, all the modules. In the past, companies have tried to create modules to sell, and they've lost money because people just don't buy their modules and create their own. But recently I've been seeing modules built for Drupal that end up using an exterior API you got to pay subscriptions for. So they're trying to kind of lock their code down a little bit, but basically this is it. So, why is Drupal the right choice for your next CMS or API? Well, when I made this slide, I do love Drupal, but I'm not quite sure it is after talking to some people here over the last few days, because the end result is it's kind of hard to set up. Well, it's obviously free, and you can get everything you want for it, but out of the box, it's kind of hard to set up. So this is a marketing slide I took from Drupal to kind of take some of their content, and that's the Drupal stats, as we can see. I'm not sure where I fall into that. Okay. So if you want to go to Drupal, there's your QR code. Okay, so we're going to get into the side of let's try to install Drupal. Last year, about a year ago, the lead Drupal project, the man who created it, he's based out of Belgium, and for many years I've been watching his keynotes, and I finally went to a DrupalCon, and I feel like I'm being negative about it a bit, but he really wishes he had the WordPress market share. He just loves to make Drupal more like WordPress for the content management side of things, for the content. People that are logging in, they can manage content, there's workflows, everything. So he realized they were losing the market share, and why? Because it's hard to use and hard to get running. So they came up with a new version, this version. It was named Starshot, but they changed it to Drupal CMS. So you have the core version that doesn't have anything really installed except the first user and maybe one page. So they came up with a different version where they wanted to have recipes, where you could select different recipes that would have the modules, like for a blog recipe, an accessibility recipe, an SEO recipe, so you don't have to find these modules in the Drupal sphere and know which options to click, set up, and everything. As I just explained. Again. Okay. We have a download that didn't turn into a link, but the QR code works. Okay. So when you go to that link, you come to this page, and I actually just tried this on my VPS, and it does work. But I also have Composer installed on my VPS, and I also have PHP 8.3, and I also have MySQL 8.0, but you can also use Postgres and SQLite. So when you get to this page, it kind of gives you some instructions, and you can obviously go to the core to download, or you can go to Drupal CMS. There is links, excuse me, to get going, and then they talk about DDev. And what DDev is DDev is based on Docker, and it actually, once you get it up and running, it's actually pretty slick. They do have different DDev quick starts for different PHP applications, and I think there's like a Node.js one, and off the ground running, you're pretty good to go to test stuff, to get stuff running locally. I've used Lando, what else have I used? Vagrant, Doxil, LAMP, XAMPP, you know, everything. When you have like 30 different sites on your laptop or your computer, you kind of need to use Docker or something similar. So there's the QR codes for that. I was going to go through an install, but I'm going to kind of see if I can. Sorry about the wait. Do I even have internet? Okay. Will it load? You guys gonna install Drupal after this, aren't you? So once you actually get into, when you install it locally and you follow the instructions, you will kind of be brought to a screen like this. Or it might change by the time you get it, because if you actually look at the URL, this was actually called recipes. So I got confused because I thought they were called recipes, but now they're not. So I don't have anything installed on here. So let's install a couple things. I'm gonna install a blog. Hopefully it's fast. Actually, hopefully it works. And maybe not. And there we go. And I'm actually going to install this. This one here, this suite of modules that this uses with WordPress will probably cost you about $40 a month USD. And to configure it and have it set up is actually a PETA, a pain in the ass. So we'll see if it actually installs. Jeopardy song. And it's installed. So let's go take a look at some content and see. There should be some demo content. Perfect. Let's take a look at this one. So this is what we got, some test content. We have URL pathing, which is nice, and let's do a Lighthouse report. Now I know a lot of people will talk about Lighthouse and say, you know, you can't depend on it or Google Insights, but clients and marketing people that I've worked with love it. And they kind of use it as a benchmark. So if you can score on this, somewhat green, and this is a PHP-driven MySQL site, then something's working. They've actually figured it out. That's my opinion, because that's what the end client is going to kind of look at if they can. I do have other things I could talk about looking at all the different slides I have. But what I'm going to show you is probably, I just discovered this last week. And I'm going to show you guys this in action, because I think this is the best part of the demo. I've worked on a lot of multi-language sites in the last 20 years, and translations has always been a problem. I've gotten Excel sheets, PDFs of different languages, working for different multi-language sites. One thing that is good about Drupal is it does handle internationalization very well, because the lead project man is from Belgium, so he wanted international use. For different languages in the string translations in the CMS, for most languages, it is there. And you have string overrides where, if you don't see the right word in your language, you can replace it. My approach in the past with earlier versions is if the translation wasn't there, then I'd have to use some kind of code, and I'll actually use JavaScript to replace things. But the modern version, you don't have to, and it's better. So let's see what, I think I have a piece of demo content on here. Yes. So I'll go into this news item. Seeming this conference is a lot about AI. So I created this when I drank a lot of coffee earlier. That's why I sound rattled. And we'll go into the Translate tab. Now I'm currently working on a menu system built in Drupal that's a headless API spitting out JSON to a Next.js 15 internationalization kiosk app. And I don't have this set up on this site for translations from Denmark to Dutch and French and Thai. So it doesn't, oh, and it didn't appear. Well, that is not good. Something is going on. Hello. And we're there. Okay. Well, let's go to this page then. So I installed the accessibility recipe because I just wanted to see it in action. I personally think this is a pain, but it's part of the free module. And let's go to Translate. This is just a demo page. So, as you can see, I've already translated one to Thai. In earlier versions of Drupal, that does not appear. But they have a suite of an AI module, API, where you can plug in a Claude API key or ChatGPT key. And so when I got this going last week, I actually flipped out how easy this was. Hopefully it works. Please work. I'm using 4.0. Yeah. You can pick different models in the setup page. We won't get deep into that because I'm sure if I had a beer and we could hang out here for 3 hours, we could set it up and go through everything and give you some code, but it's beyond the scope of 25 minutes. And we'll translate the Hindi. But you can pick your agent, then you can pick your model. I had a hard time setting it up actually because I had an older API key in ChatGPT AI and it didn't work. So Drupal has many Slack channels, and they're really trying to push this with content translation. There's actually plugins in this module to help you out with content and find accessibility issues, but I didn't turn that on yet. I figured this demo is good enough. Hopefully it works. There we go. So, I think minus the translations in the past to set this up would have been, I used to I don't know, a week of click, click, click site building and testing and making sure the URLs and everything is handled right. So what we'll do, this is the best way to do it. I did show this to somebody who speaks Hindi, and he was looking for faults, and he did find a few. So there is a content flow moderation. You can make different roles and groups and, you know, have somebody send an email to make sure it's the right language and it's the right flow. But in the past, this would take days of emails back and forth. And I kind of think that is going to be the end. So yeah, so when you do install it with DDev, you'll come to this screen. My suggestion is to skip it or try it out, get through it. You'll come to this recipes page. The internationalization isn't a recipe, and I was kind of wondering why. And because they are not cognizant on what languages will be installed. But what I might do, another part of Drupal, all this config that's not content, because content is something different in Drupal, can be exported as YAML files. And what I might do with this site is I'll try to export everything, and I tried to, but it kept exporting my API key for ChatGPT and get it out so you guys can download it and with the DDev and give it a go. And yeah, if you have questions, find me, stalk me, and yeah.
Okay, anyone has any question about Drupal for Mr. Chris?
Hosting.
Yes.
And I will have a link to the slides.
Cool.
Any questions?
Any questions? We have time for maybe one short one. Okay, if not, Mr. Chris has also uploaded his slides on Event.ye, so that's also another place you can check it out. Of course, always feel free to connect with him, right?
Anytime. You know, I don't mind helping out. If you run into a problem, I can give a hand. I will try to put that multi-language site up here and make it public and working. Thank you very much, everybody.
Okay, thank you, Mr. Chris. Yeah. Okay, can we have the next speaker? Yeah, come. Yes, Chris. You want to use this or? No, I use this for the notes. I see. Yes.
Modify from PHP too? Modify, customize it, you also use PHP?
You can, just like based on symbol. So if you want to customize the front end, just like they have Twig as the front end things. But if you want to make a custom module, it's optional. So
Okay, what language?
so that was so when I
What's the one that's
You want the speaker notes?
similar to that but it's in Python?
Is it okay?
came out along time ago,
You need to, you need to get it. You need to connect this. Okay, welcome to the web and mobile track. Our third speaker is Mr. Gun Josny, co-developer of StandardDeep, and his topic today, numeric and scientific computing inside your web browser. Right, let's welcome him. It's a 25-minute talk. Yeah.
Hey everyone, happy to see you all around here. So today I'll be talking about numeric and scientific computing inside your web browsers. So I am Gun Joshi, a core contributor at StandardLib. StandardLib is a fundamental library for numeric computation on your web browsers, similar to like what we have NumPy or SciPy in Python. Let's get started. So first of all, I want to motivate why do we need to perform computations of any kind inside our web browsers. Basically, there are 4 key reasons for that. First one being instantly accessible. You don't need to install anything else when you are computing inside your web browser. So there are no external dependencies that you need to install. Just your web browser, your Chrome, your Safari, whatever you use, and that's enough. Second point comes out to be for privacy and security. So the data which you are using to compute anything stays inside the client's machine in your own device. So the data isn't being transferred to any undisclosed location where the server is located. So you have your full data privacy because the data never leaves the client's machine. Then comes the point of low latency. So as the computation is being performed on the client side, you don't have to face network issues, sending data over to the server, then it comes back. Latency becomes very low. Then you have major point of accessibility. So client-side computation can be used to enhance the accessibility of your day-to-day web applications. So even if you have a low-end device, you can use web-based computation for some assistive technologies. The demos for some of those things we'll have later in this slide. Yeah, so I have some demos ready for you. So these demos will help you visualize what are the different fields in which web-based computation can help us. So first of them is a digit classifier. This is based on TensorFlow.js. So suppose we have a digit, we create it, and then it detects what we have drawn. Similarly, if we have we draw any number, it gives the probabilities of these digits. So it detects 7 as 1, but it works sometimes. After that, we have an toxicity detection. So sometimes what happens is, there are various social media platforms. You have multiple comments on any post. What if you can, detect which comment is toxic and which is safe? That can be also done on your web browser. No need to, send everything to the server. Such as, suppose someone says, this, and then we try to classify it, it detects it as true, so it is toxic. But if there's a normal thing, it says no, it's not toxic. So this is also one of the use case where we can leverage web-based computing. We also have multiple OCR features. You might have heard about OCR.space. So that what it does, when you upload an image, it sends the image to their servers, then they extract the text out of it, and then they send it back to your client, to the client's machine. We don't need servers for OCR such as Tesseract.js. what they do is they also have the entire computation on your web browsers. So suppose we have a sample image here, they extract the text out of that image and display it here. This is entirely web-based. After that, you can also visualize training an entire ML model inside the web browsers. Yeah, you can do that as well. So this is a simple visualizer where you can visualize a model being trained without a server being involved. So we load the data here. We have some digits example from MNIST database. You might have heard about it. And then we can start training our model. So all this is happening on your web browser. So like the hardware of the client is getting used. We have some custom training charts, accuracy, confusion matrix, all those stuff. After that, some accessibility applications are also there where this comes of quite a good use, such as WebGazer. What we can do in this thing is, first we have to calibrate it. So what it does is, based on my eye movements, it tracks my eye movements and then it moves this red dot around the whole screen. First there's a process of calibration. We have to calibrate some of these points on the screen. And then once it is done, it is able to track your eye movements. So see, now wherever I take my eyeballs, it just moves the red thing also. One such more use case is HoloBooth. This is similar to WebGazer, but what it does, it instead of tracking only your eye movements, it tracks your entire face. So as I turn my head, this also moves. So these were some of the demos. Now let's go ahead with some distribution and communication of scientific results. So scientific computing is not only about computing and getting the results. It's also about how you share those results, how people from the whole community can get those results. So for that we had Nature plus Jupyter notebooks, traditionally what we were using, but those notebooks have some problems with them. The problems include those notebooks are not built for production. They need a backend. So what if we can achieve all that without a backend? We'll have a look at that as well. As they need a backend, their deployment requires special infrastructure. Hosting these Jupyter notebooks, it requires dedicated cloud containers and containerized environments, meaning those are expensive. And there are security risks as well. Arbitrary code can be run inside these Jupyter notebooks. What if someone runs RMRF or some malicious code? You're gone. Difficult version control. So as the Jupyter notebooks have JSON based format, so that makes tracking of version changes a bit difficult because the differences are a bit noisy and large. So in order to tackle all these challenges that we had been facing, we have some web based notebooks. So what these kind of notebooks does is that they do the entire computation inside your web browser. So they run entirely inside the client's machine. Web server is required only for deploying that websites, not for the actual computation. So those turns up in lower cost and faster accessibility. Here is an example for one such web-based notebook where we do real-time k-means clustering. Let's have a look at that. Yeah, so this is one such observable notebook. So this platform is observable. So through observable, you can run JavaScript code in these kind of notebooks. So let's see. Yeah, so we'll start the k-means clustering. Just uncomment this line of code and we'll just play it again. So you see, the clustering is happening directly inside your web browser. So no need of a server or a different computation environment. Your own machine is getting used over here. And this is all happening in the client's machine in real time. Now we're talking about scientific computing. So now let's break down what are the key ingredients that make web-based scientific computing possible. So the key ingredients include syntactical niceties. We should have some, syntactical sugar for web-based computing. One such example of that is R's pipeline operators. So instead of doing, first taking the square root, then mean, then some C function, you can just have a pipeline of operators, one of the features of R. After that, we have some site extensions as well. We just saw observable notebook, which is used to run JavaScript. So site extensions, what they help us to do is they help us to compile our code inside the web browsers. So observable for JavaScript, Jupyter-Lite for running Python, and there are a few more as well. Scientific computing ecosystems also require bindings to some hardware optimized libraries such as BLAS, which is basic linear algebra subprograms, or linear algebra pack, popularly known as LAPACs. So what they do is they use SIMD or vectorized operations to run the code at near native speed, again in web browsers. There are also some data structures tailored to numerical use cases, such as ND arrays. Most of you might be well aware of those. So what we are doing is we are importing NumPy, we are initializing the array, and we are getting the shape of the array. So those kind of specialized data structures, they help us in scientific computing ecosystems. One more such example is of data frames in pandas. So what we're doing here is also similar to, like, we're creating a 2D table with name and score fields, setting up with data, and then using it. One more important thing comes out to be for vectorization. So what vectorization is, suppose you have an array of data. There are many elements in an array. Now suppose you have to perform the same operation on each element of the array. Traditionally what you would do is, running a simple for loop and running the same operation on each data, each element. That happens without vectorization. We're just using a simple for loop here. But if we use vectorization, the whole array is processed at once, so there is no need of computing each element multiple times. We can have all that operation on the entire array at once. This is one such example to understand vectorization better. So let us suppose we have a function that calculates distances using latitudes and longitudes of two places on the earth. So this is our helper function. So what we'll be doing is we are also generating a pandas data frame which has random coordinates of many different places for testing our data. So then what we do is we first generate the distances using a for loop. What we'll be doing here is we'll be comparing using for loop and then without using a for loop, using vectorization. So in this case, we are using a for loop to calculate distances. Just notice here how many times are we calling the function here. The calculate distance function is being called multiple times inside this for loop. So whatever is the length of that data frame, the function is being called that many number of times. But if we use vectorization, we need to call the function only once, and the operation gets performed on the entire array all at once. And then when we put all those things inside the chart, just notice the difference here. The green one is for loop, and the yellow one is for vectorization. So there is a tremendous amount of difference in the time taken for computing those things. So that is where things like vectorization comes out to be handy. One more ingredient of a scientific computing ecosystem is specialized and domain-specific libraries such as scikit-learn for machine learning or statistics or something like that. We have stats models as well for statistical analysis and different kinds of numeric and scientific computings. Now, we talked about the ingredients of an ideal scientific computing ecosystem, and there are many libraries and frameworks coming out these days in recent years. There is a shift towards web-based computing, and things like TensorFlow.js or StandardLib, Math.js or D3.js, Plotly.js, you might have heard some of these. So these are the key players in this kind of environments. Now, what really is exciting about this point of time is that we are on the cusp of a burgeoning ecosystem for a web-based scientific computation environment, an ecosystem which will power and supercharge web-based applications of the future. And one such key player which is striving to make that difference is StandardLib, which is a standard library for JavaScript and Node.js. It provides a common foundation with standardized APIs atop which others can build domain-specific packages. Let's revisit the ingredient list that we saw earlier. We talked about syntactical niceties. Similar to how R has those pipeline operators, StandardLib comes along with fancy indexing, just like we have in Python. So this fancy indexing that works in JavaScript, similar to that Python thing. So what we are doing is we import the array to fancy function from StandardLib, initialize the array, and then we retrieve the slices, assign the slices, and then modify the array. One more such thing is BLAS bindings, which are basically linear algebra subprograms. So what we are doing here is, just notice, we are just importing the modules which we need. We just imported DAXP and float64 array. So there is no need to importing the whole StandardLib package. We can just use simple smaller packages that we need, which can reduce the burden. We also have LA packs, linear algebra packs. What we do here is, we are doing here is just importing the packages that we require, performing the DLA CPI operation. So what this operation does is it copies the data elements, all data elements or only some data elements based on the inputs from one array to another. We talked about ND arrays as well. Similar to that, in StandardLib we have ND array support as well. While initializing, we can give the arguments for buffer, shape, order, strides, and offsets. And based on that, we can use ND arrays in JavaScript in web browsers, similar to how you do in Python. There are some universal functions. We talked about vectorization just now. Similar to that vectorization in StandardLib, what we can do is we first importing the ABS function. We import an array, and what we do here is we have this array, and instead of computing the absolute of each element one by one using a for loop. What we're doing is we just call the function once and the operation gets, worked on the entire array all at once. It also has a read eval print loop environment, so which comes up with customizable themes and syntax highlighting and more such features, so you can play around with this REPL as well. This particular example demonstrates the famous PageRank algorithm which Google uses. So what happens is, at a high level, first I just want to bring your attention to the packages that we are importing here. These might seem a bit lot, but that's actually an advantage because we are just importing all those packages that we need rather than importing the whole standard lib library, thus decreasing bundle sizes. And all these things can be, executed only with the help of standard lib functionality. So, no need to import this library and this library and this library. Standard lib can be your one-stop shop for whole numeric and scientific computing. Talking about computing on web browsers, how can we miss WebAssembly? So WebAssembly is a if some of you might not know, it is portable, consistent, high performance binary format for web browsers that helps us to execute code at near native speeds. It also comes up with SIMD optimization. So what SIMD optimizations help us to do is single instruction on multiple data things. So you have a single instructions and that gets executed on multiple data elements all at once. We talked about WebAssembly. So there are also many ports of entire gaming engines getting run inside web browsers using WebAssembly. So what is this happening is this entire game engine is running inside the web browser. So no server is involved in this as well. This is using WebAssembly along with Unity's engine. Adobe Photoshop is also a good example for this. So their entire image editing software runs inside the web browsers. So this, when they converted their software for the web, what they saw is, they achieved up to 200% performance improvement in their model execution. So that's like near native time, real-time editing capabilities in your web browsers. Here we compare JavaScript against C and WebAssembly for the blast level routine DAXP, which multiplies a matrix which is a constant and then adds that to another matrix. So in the plot I'm showing two different WebAssembly measurements. First is labeled as WASM and second is labeled as WASM copy. So for the first WASM measurement, I'm measuring WebAssembly performance when we are already have been allocated memory inside the WebAssembly module heap. So we already have the data inside our WebAssembly memory module. So but for WASM copy, we don't have data pre-allocated inside our memory module for WebAssembly. So in WASM copy, what happens is first the entire data is copied inside the memory module for WASM, and then the computation is being done as expected. So WASM copy performs a bit lesser efficient as compared to WASM. A few more efforts for numeric and scientific computing on the web have been made by Pyodide. What Pyodide does, as standard lib helps you to run JavaScript for numeric and scientific computing on web, with Pyodide you can use Python over the web. So all your NumPy or those functionalities can be used inside your web browsers. Similarly, WebR can be used to compile R and use R operations inside the web browsers. But you might ask, so if it's possible to run Python inside web browsers, then directly why shouldn't we use NumPy or SciPy? Why to go for standard lib and why to go for JavaScript? While this is possible, doing so comes with significant disadvantages. So based on these charts, we can clearly see the differences in loading time. This is what Pyodide takes, Pyodide with NumPy, and this is what standard lib takes. That's like exponential difference. Similarly, in performing multiple operations as well, based on speed, there also standard lib either outperforms or is at par with NumPy. So there have been multiple efforts such as Web AI, where you can run entire AI applications on the web using Chrome, WebNN, and Web GPU as well. So with Web GPU, you can use GPUs inside the web browser, so no need to use clients, use GPUs in cloud-based environments. So finishing my talk, if you really want to get involved in standard lib, you can just scan this QR codes. This is the link for standard lib's repository, blog, and the GSOC page. Thank you.
Thank you, Mr. Josny, for sharing about all the exciting possibilities in the web. Right, so we welcome the next speaker, Mr. Amon. Are you here? Oh, okay. You use your net or the?
Yeah, I use my own.
Okay, so you connect this.
Hello. Yeah. Okay, sure. Yeah, no,
It's a 15 minutes now. Okay, good morning. Good afternoon. Welcome to Web and Mobile. So the next talk is a shorter talk, only 15 minutes, 15. But so we'll give the time quickly over to Mr. Amon. Yeah, on this topic on Flutter. Yeah. Thank you.
okay. Hi everyone. So this session I'm gonna talk about how to scaling a banking app with Flutter. So my own experience for 5 years in Flutter. Let's see what we have. Okay. So what is scaling and why we need scaling? The first one is once you start your project, right, and you keep going on your project, each time that you on top of the new features, your work will getting slower and slower, because the first time that you come to the project, you working on the login pages, right? And it's pretty much so simple because it's the first feature that you make, and you don't have to worry about the existing feature that is gonna broken or not. So that's why when you come into the really first project, it go really fast. But since when you keep going on the same project, it will getting slower and slower. And people will let's put more people into it. But it's not working that way because of the scaling. So let's say your work is 1 man day, right? If you put 2 or 3 people, it's supposed to be 3 man days. But it's not working that way because of the scaling. So they have something called degradation. So it's not the linear things that you put 3 people and you multiply by 3 and you got 3 times performance. It's not that way, right? So every time that you put more people, it will slowing you down. But it's not completely slow down. Let's say if you put 3 more people, your performance might be 2.9 or 2.8 or something. Yeah. So the problem is because we didn't prepare for scaling. So how to minimize this one is called degradation. So the first one is you have to plan for scalability for your application. I will talk about this later. And the architect of your app, when you join the app, when you first start the application, I'm recommend that you're not gonna use like clean architecture or something like that because it's too over-engineer. That's why we come to the third one, that you shouldn't like over-engineer things too much. And scaling a Flutter app, in my own opinion, and my own experience, that I work on the iOS for about 10 years as well. So it's a little bit different approach between Flutter and native. So native, if you have a big project, sometimes from the fresh start, you might need up to 30 or 45 minutes to start your project from the first build. But in Flutter, you don't have that problem because they have a feature called hot reloaded. So when you change something like color or text or maybe a little position of X and Y of this text, so it will keep the state and you can reload it like under 1 or 2 seconds and you can see the result. But when compared to a native that you have to like rebuild it again, it might take about like 30 seconds instead of 45 minutes. But it will reset all the state that you have. So let's say that you're on the page 10, like in register form something. But if you rebuild it, you have to start from the page 1 again. But Flutter is not like that. So, I didn't introduce myself yet. So I'm a mobile lead engineer for the Make by KBank application. This project is another financial from the Kasikorn Bank. So basically, why we have two applications. The first one is the basic idea is put the whole bank into your application. So you can do all the stuff like loaning, renting, like buying a credit card, whatever you like. You don't have to go to the bank. But this one, we aim for the different approach. Our approach is we put you and your life into the bank. So we engage more into the social. We didn't plan to put the whole bank. So we don't have like renting, loaning, or buying credit card, but we more prefer like social engagement with the financial application. So the topics will be 5 years of evolution and how to scale it. So before we talking about scale, we have to talk that some context is good in some time. What to say? So basically, best practice, you always heard about it. Best practice is not the right way to put. So let's say best practice should put in the right context, not like when you start your project, you start with like, let's say, microservices, clean architecture, all the cooling stuff that they say that is a best practice. Google say that, like everybody, the big companies say that, but their context is different from your context because they talk about, they have a big project, they have a ton of money to burning, but you just start with 1 or 2 persons. You shouldn't like copy paste from their idea into your project. So as I mentioned that we have different phases and we have different contexts, so we have to use different strategies. So the first concept is my startup mindset, right? We use Flutter because it's rapid prototyping. It's fast, it's good enough, let's say. If you compare to the native, it's not fast like native, but it's good enough to start your project and it's good enough for the user to use it. Good enough for your user is 60 frames per second. Over than that, it doesn't see any different. So the first phase, we use Flutter to validate idea. We have our own idea, but we want to ship fast. We want to validate it, that our idea in our head is that valid in the whole market. So after you ship this one out, you will see the result from the users that your own idea is correct or not. So we come to the second phase, pivot phase. Pivot phase is like you think think that your feature will be looking cool and everyone will using it, but once it go into the market, everybody use it differently than your idea. So you have to pivot based on your customers. So you have to use some analytics like data warehouse to see that which way that it should be in your market fit. The third one is growth phase. So now we will be talking about the scaling, because right now everybody like your products, they know that what they're gonna do with your products, but how to make it grow up. So you have to have more people, because the feature people using it, they like it, they want to have like the next version. So you have to have more teams, more scaling. So scaling is like more teams and more code base that should prepare for scaling. So the fourth one is maturity phase. So it's the business, right? Everything is central about the business. You work on the project, you want to earn some money so your project can keep going. So what we learned for over 5 years, the first one is data-driven mindset. No imagination. This is my word. No imagination. You need validation. So it's not like you think that it works. No, it doesn't work that way. You think it might work, but you need to validate with your customers that it really works or not. So we have to have data mindset. Even all analytics that we have to use all the stuff to have this information to improve your application. The second one is automate everything. So basically when you grow up, your project is growing up, you have more tasks to do. Basically you don't code anymore. You have to look into analytics. You have to do some like monitoring your performance, your app, your production issues. So most of the time your coding time will be less and lesser. So how to make it like catch up with the tasks that you have, so you automate things. So you find out that what tasks that you can do automating, turn it into automate. But don't everything, because sometimes it's so hard to do the automate. You might need some manual tasks. And CI/CD is a must. At first I thought that it's like just one people I can do like unit tests and I can ship by myself. But after we have like 12 people, everybody trying to shift their features into the testing environment. So this one is like, yeah, it's a must for the scaling. And the last one is keep it simple, because as I mentioned is don't copy from the Google, because you have your own context. So not go over engineering. So you have to balance between keys, keep it simple, stupid, and dry, don't repeat yourself. If you don't want to like very clean architecture, very clean stuff, but your feature is not going anywhere, yeah, that's not how business works. So balance this one. But for myself, I prefer to under engineering a little bit, because code is cheap. For myself, we throwing the code like maybe 2 or 3 days, this code is duplicated and we throw it away anyways. So don't to like think too much about the futures. So best practice is not a light practice for you. So to sum up, the practicality over perfection. So you do it first, you ship it, make it work, but make it right later, because you don't know that what is the right choice for user. So you have to make it work with the high standard as well, right? Not like make it crappy. So make it work and make it right. So for the scalability, yeah, so in the mobile application, we have to concern about 2 things, the performance optimization and productivity efficiency. As I mentioned, that your work will getting slower and slower. So the first one, the performance optimization, is about API calls. So you don't go like your server is like the God server that you can go crazy every pages that you call like multiple API without thinking about the resources. Yeah, you have to think about it. Like a caching, lazy loading, the offline support. And efficiency, like, because if you have like 12 people working on the same project, you want to have everyone body have the same knowledge as you. So we use some automate tasks like code scanning, learning, automate some tasks, feature flagging to ship the feature first, and if it's broken, you can turn it down. And analytics, or the alerting system, and testing is one of the fundamental to do some to reduce the degradation of your project as well, because you don't want to, like, if you have 200 features in your application, you don't want to retest all over again if you just change something a little bit. So this is our mindset, and we think that the result is like we are the most loved financial app in Thailand. So over 4.5 stars on both iOS and Android with a 250K reviews. So our mindset is practically over perfection. We ship it first and we make it perfect. So over the key takeaway is scale smartly. So as I mentioned, don't copy paste from the best practice. You have your right context. You have to think about it when to do it. Efficiency wins. So as the project degradation, you have to minimize it as much as possible. I know that you cannot like make it zero, but yeah, with some like optimized processes, automate tasks, and try to eliminate waste. And user need evolve, because even 5 years ago we launched the product. These features still need evolve over time, because user they have their new knowledge, their new things to do. So yeah, all the analytics that you have. So this is the key that we have for the scalability. Okay, thank you.
Thanks very much, Mr. Amon, for sharing his insights and practical advice on Flutter. Right, it's a short talk. Please, if you have any questions, please feel free to engage with him, Mr. Amon. Yeah, maybe at the back or in the hall. Yeah, so we will get the next speaker set up. Right, so the next session is actually a workshop on Pygame. Is 55 minutes. So if you would like to have some hands-on on how to do a typing game, right, so this is a workshop for you. Right, it will start at 3:10. You want to start, is it?
Okay.
You upload it here. By PDF.
Yeah, so how do I need to download it, right? So I
No need,
download
no need.
this.
No, no, you want.
This one is downloaded, right? Oh, what does it say?
No. Is? No. Okay, first you should be able to get it directly.
We can't display like that.
It's a PDF file.
Yeah, we need to download first.
Okay. You can't display the PDF file in the browser? Let me see.
You can, but not from the Google Drive. You can't present. This is too small. Yes.
Okay, welcome to the web and mobile track. Right, this is the second last session. Right, so for this talk, actually it's a workshop, so it's going to be longer, 55 minutes, and it will end at 4:05. So the title of the workshop, according to the schedule, is Recreate Old School Game of Typing Tutor, but it's actually using Pygame, right? So our presenter is actually Ms. Ao Chung Yun Ling from a startup software consultant from National University of Singapore, right? So we'll pass the time quickly over to her. Thank you.
Hey, welcome. So this workshop is meant to be very fun. So if you have your laptop, you will be having fun. Okay? Be great. All right. So the typing tutor game, just a very quick introduction what the game looks like. It's just words falling down from the screen and you have to type the words accurately, get it off the screen before it hits the bottom, which is where your city is. And it hits the bottom, it will destroy the city. Right? So very simple. Okay. So what do we need if you want to recreate this typing tutor game? It's a very old school arcade game, right? So all we need is just Pygame, know how it runs, and just create the city line. That's it for this workshop. We won't be going through the details such as scraping of the words for the game, all those things we won't be going through here, or leveling, or even adding sounds or animation. Well, we will have some animation. But those you can actually find out from the website if you are interested yourself. And what I'm going through here today is actually all also on the website if you want to look for it. Okay, so first thing, of course, clone the repo, and then you can start. So this game, what do we have for this game? Of course, the user, right? And the user types. If it types the following words correctly, it destroys the word. If it does not type the words correctly, the words destroy the city. Simple? If there's any questions, feel free. Raise your hands. Okay, so for this game, as long as you have cloned the repo, so I've already prepared all the workshop files. So this is kind of like a glossary of all the workshop files, the folders, sorry, workshop folders. So the source file, basically it has the full gameplay. And the workshop directory, just plain WS, it has the skeleton files. If you want to just have the skeleton files and try to create the game with your own typing own words, feel free to use that one. And then as we go along the workshop, basically we'll go through and say, okay, this is workshop 1, 3 files. You just compile that one, and then it would be for that workshop. Yep. Okay. Okay, so and basically you can see this is what we'll go through. We'll go through, okay, how to install Pygame, and then how to create events in the game, how to display the text on your game screen, the gameplay itself, the different objects that we put in, how to animate, how to detect the typing key presses, and of course, how we build our city line. Questions? Am I going too fast? No? All right. Okay, so I actually, the first time I did this workshop, about 5-6 years ago, it took me more than 3 hours because all the people was like just trying to type out, and we don't type that fast, right? Okay, so simple things. Pygame installation. All you need, seriously, just pip install Pygame. Have done that? All of you have done that, and give it a try. All you need to do is navigate to the source folder, run the game. Then you can figure out very quickly how it runs. And now if you have run the game. The GitHub repo is right here. Got it?
I'm fixing this error.
Module.
No
Pip
module.
install. You did it install, right?
Yeah, let's try again.
No, not pip install.
Oh, pip. Oh, okay.
You got it? Sorry.
Huh?
Okay, got it.
Oh, you stopped it. I think I
Okay, some of you got it.
the window show up nothing.
That's you need to run it, or you run it from the source, right? Python dash game. That's odd. That is very odd. Huh. You have Python in here, right?
Right,
And you have just installed Pygame.
right.
And you have just cloned the repo.
I use a condat, I'm not sure.
Yeah, I'm pretty sure it had worked.
No, this is I try the control C.
Mhm.
Sorry.
Let's try this again. Got game. Okay, should be okay. Still not good. Why are this? Oh, this is a very odd. Sorry, I probably need to Control C. Okay, this is fine. Don't worry about that one. So, sorry. Would you try installing .-u Pygame again? Okay, some of you are playing the game. Okay. Pip install .-u Pygame. Python. Okay. Okay, I'll get back to you. So next. Okay, so now that we have installed Pygame, so next, okay, for the next step we have here is just to import the Pygame package and then initialize Pygame, and then that's our entry point. Seriously, for any Pygame out there, this is all you need, right? Define the class and run it. Right? And then next we want to define our game display surface area. So this is basically where our game will be running. And we have gone with the size of 640 by 480, very standard console size. And then we set the game title. Right. This Pygame display set caption is where we set our game title. And then we just load it. That's the game surface that we have created with the title, and we just load it. So with this, next we want to set up the game loop. How does it look? Alright. And then once we set the game loop, it's just it. We want to check for events. Very simple. We want to check for events. What are the inputs, the user inputs that's happening? Right. So that's the user events, and we want to detect whether or not the user press the red cross on the top of the screen to quit. And then we stop the running. We set the running flag, we stop the running. Simple. And that's it. If we execute the game from workshop 1, that's all we get.
I think something is very wrong with this install of Python because it should not be crashing with the, yeah.
So have you updated? Have you updated?
It said that Pygame is installed already, so.
What does it say? Sorry about that. Unfortunately, I think you something with your version is not compatible. Anybody else on yeah, they're running on MacBooks as well. Yours are running fine? Yep. Yeah.
That's weird.
Yep. Yes.
Maybe actually close it. Workshop 1?
Yeah. Doesn't work for you? Did you make any changes? What's the error? You could run workshop 1?
I already ran, but what I need to change here?
No, you don't need to change anything. That's it. Okay. Sorry, because of time limitations, we'll just carry through. Just follow my description and you can go home and give it a try yourselves. Right? Okay. So that's workshop 1. That's all you have for workshop 1. So, and then next, we go through to the game state. What are the game states? Every single game you have, you start the game, you play the game, game over. Very simple. Right? Start, play, game over. So we set up the states, and then we say, okay, just a space bar to run through the states. We just need to go from state 0, 1 to 2, right? We run through the states. So space bar to go over the different states, and that's it. So once we have set it up, and then we display the feedback of the state so that we know that, okay, yes, this is at what state. We just display the feedback. We put the surface area. We fill it up with black. And then we bleed the text. Right? Remember here, we put up the states already. So all we need here is to literally just render text. We have the black color for the screen. Bleed is basically block transfer. You're transferring the image to the surface, the game surface, and then you flip it. Basically, you're updating the screen, refreshing the screen. Now we define our text, right? What text do we have? We have the start, playing, game over. Simple as that. And same here. What we do here, we draw the text, we prepare for the rectangle where we have our text. We just need to prepare the rectangle, the color of the text that I've defined as green above, and then we bleed it to the surface. Okay? And this is workshop 4. And then we add our text to display the different states. Right? Because we have already prepared our function, it will bleed perfectly. And then if you run workshop 4, that's what you get. Okay? Simple. Okay, next, workshop 5. What we do now is we actually go into the gameplay itself. So similar to game.py, So what we have previously is just we have all the codes on game.py. Now we just prepare a new file called play.py. And inside play.py, we'll put in our gameplay itself. Right? So we prepare the fonts first. What are the fonts we want? So previously, we just put a big font on top of the center of the screen, 32. Now we have calculated, okay, now we want the font size 16. And then we just said, okay, now we have our gameplay, which is different from our starting screen. From the game.py, we go into play.py and out. That's it. Right? So now other than the key press, other than space bar, if you hit escape, that would mean game over. Okay? Now for our game, we want to differentiate the playing of the game from the start screen. The start screen is black. The game itself is blue screen. Right? We just draw the word playing for now. We are not going to do anything about it. We just put it on the top left coordinates, which is of course 0, 0 right there. And then we bleed the screen. Okay. Then from so from game.py, you want to import play.py, right? So we created the gameplay in play.py. So we import it, and then we execute it from game.py. So when we execute game.py, we will go through the states, and when the state goes to playing state, we go into game.py. Simple? And that's workshop 5 for you. Okay? All right. So now let's look at the game objects. What game objects we have? Not a lot, just the words. Right? So inside our our objects.py, what we do have to do? Initialize the words. The words that we use to be falling down from the screen. So here I've already prepared the words list for you. It's inside the resource folder. Basically scraped from the Gutenberg library. Basically the brown.txt is where all the words are. And inside basically we has all the words already. And then we just grab it from the resource folder, the word.txt. And then we strip it of all the unnecessary things just so that we tokenize. This is what we call tokenizing, right? We tokenize all the words so that we know that okay, each word is which of it. And then now we have our word list. We shuffle it up just for randomness. And next, we want to include these objects from play.py. Now our play includes objects, the game objects itself. And then we create a word.py so that we can have all the methods required to manipulate all the word objects. Simple manipulation that we need is, of course, getting the x and y of the word. So each word, when we create the word for the game object, we want to initialize it with an x and y. We randomize it for now, right? We just give them the limit of the randomization from the x-axis and sell the y-axis. Y-axis is, of course, always going to be the top, basically about 20 from the top. And maximum, it will fall. And then the x is basically the length of the screen, right? Minus the length of the word. To prepare for that. So it's easy to calculate the length of the word by multiplicating it with the size, the font size. Okay, so we know that the font width based on the Consular's board 16-point font is always 9. So you multiply it by 9 with the length of the word, you get the size, and then from there you calculate your max and mean of your randomization of your x-axis. And when you add word, that's where we get our x-axis. Okay? And then now we want to add the timer to add the word. So we don't want to add the word for every single computer cycle, right? We want to add the word in intervals. So we put a counter in there, right, to get the pi time get the ticks to make sure that, okay, once the timer has run out, then only we add another word. Then of course, once we add the word, we have to draw the word. So this is where we draw the word inside the render function. Right? We create a method of draw word already, right? And we want the word to be white color against a blue background. Then we draw it like so. Okay? Any questions? No? Okay, following. Okay. So next is animation. So most games have certain animations, right? So how do we control the animations? For here, I put the FPS of 25. That means the frame rate, frames per second of 25 frames per second. So it's pretty much okay for most situations. 25 is actually quite quick. And then of course we get the FPS of the CPU clock. And then we want the Y delta to be 1. So for every frame, we want it to move by 1 pixel down. And then we just add a tick. So we move it by 1 pixel down, right there, the Y delta. Okay, so the X doesn't move. We have already randomized the X, the location of the X, and then we just need to move it down. And then that's the move method that we add into the word.py, word.py. Now you need to set the boundary of Y. We know that we drop the word from the top of the screen, roughly 20 pixels, and then we want to say, okay, where is our city line? Let's set our city line to be around the height of 40 from the bottom of the screen. So all we need to do is minus the boundary. The boundary of Y we calculate is just the screen minus the 40, right? So once it hits, the word goes past the 40 Y-axis from the bottom. That means that, okay, it has destroyed a city, it gets to be destroyed as well. So that's the boundary of Y. It just moves from top to the bottom. And then we want to create a remove function. All we need to do here, what we do here is just we set a flag for remove. And once we have detected that is the word, there's a flag in the word that says that whether it's typed. If it's positive, means that the user have typed to which character on the word. If it's -1, means the user has typed correctly the word. So now remove the word. You want to destroy the word if the word has been typed correctly. -2 means that the user has not typed it correctly. It has moved past the boundary Y. So you still want to remove it, but the user hasn't typed it correctly. Okay? I think might be the other way around, whichever, so either -1 or -2. Okay, so now you have your animation. The words now move from the top of the screen down. Okay, next, city line, collision. So for all games, there is always collision. When you play a shooting game or whatever game, right, collision happens. That's where we want to detect the collision, that something has happened. Detected collision, we want to destroy something. So how do we detect how do we create the city line? This is how. So the city line we know is all on the bottom. It's just one line from the bottom. So we just randomly calculate the height of the block. We consider each city a block. At the bottom of the screen, you give it the block size of 10. We divide by 10, and we say that each 10 pixel is one block. And then we randomly give the height of the block. And then from the height of the block, we can calculate, okay, do we need a straight line here? Because if there's a difference in the height, we need a straight line. So it's very easy to draw the line. So this is the function that draws the city line, and the function to iterate through the different blocks at the bottom of the screen. The function to delete the blocks. This is just a negative, whether it's a -1 or a positive. The positive is, of course, the height of the block. -1 means that it's been destroyed, so don't draw anything. Right? And of course, to check game over. For the check game over, you just check that if all blocks is -1, means it's game over. Simple, right? Next, we have some helper objects. It's literally just the city iterator for us to get through all the blocks at the bottom of the screen. Right? And then, of course, we have to add the city line in object.py and to check for collision and check for game over from the object.py. Okay? So we have created all the functions in the city.py. We are just adding it into our main game. Same thing for the play.py. Now we use the light blue color for the city line. So remember our gameplay was dark blue. Our city is now light blue. And then we initialize our city itself. We render it, draw the city based on whether or not it's been destroyed or not. For each render literally means each frame, we have to redraw this. And for the add word, we also check whether the game is over before we add a new word. Okay? And here we just update game.py. That's it. So in game.py, we check for the available blocks. Here we just add a little bit of basically remembering basically add a little bit of difficulty to the game. So we don't just drop the words randomly. We check whether there is a city block below. There is a higher chance of appearing a word on top of a city block. That would increase the difficulty of the game and make it more interesting. Right? So that's why that we check for the available blocks before we do the randomization of the word. So it looks like this. So you've noticed that, okay, if there is no block, there is a lesser chance of us having a word here. Okay? All right. And of course, the score is very simple. We calculate the score by how many words we have typed. Each character is just 1. And then, yep, and that's actually it for the game. Now we have about 30 minutes for you to play the game. So I'll come help you with your game. And for the rest, let's see if you can beat this high score. I played this on a mechanical keyboard, so for those, I think using Mac keyboards, you actually have an advantage. You most likely can get 400 over easily.
Oh, hi, welcome everyone to the last session of the web and mobile track. So our last speaker is Ms. Josna Gupta from Visa. She's a staff software engineer here, and today she will be sharing with us about the Go compiler. So without further ado, yeah, it's a 15-minute talk. Right, so let's pass the time over to her.
Hello. Yeah, thank you everyone for joining today. And I'm Jyotsna, and I'm really excited to be here to talk about something that often feels like that it's a black box, right? That is Go compiler. So, but before diving in, I'll just share a bit about myself. So I'm Jyotsna again, as mentioned, and I currently work as a staff software engineer at Visa, and I've been working in payments industry for a while, and prior to that I worked at Gojek as a senior software engineer, and I have been working in Golang for the past 6 to 7 years of experience. And apart from work, you will find me running communities or playing badminton or etc. So I run Women Who Go Bangalore chapter in Bangalore. So, and apart from, so if you see the right hand side, these are my current positions or achievements or whatever I'm contributing towards, and that's that side, it's my past contributions or involvement with the community side. Yeah, that's all about me, and let's start. So I just, before, like I'll take a pause here, I just want to understand how many have you used this Go build tool ever? Anyone? Okay, I see 5 hands here. So yeah, it looks like 4 to 5 people have already been aware with Golang or used any language, any program, written any program in Golang. So it's a very powerful tool, but for us as a developer, especially when we are fresher, right, we just use this tool and it looks like that, okay, you write the code and then hit this command and finally you find the executable, right? But actually it's not a direct process. It involves a lot of multi-steps, and I'll share what are those steps in detail today. So if you see, these are the steps, multi-level steps, and there are a lot of steps. I'll get, like, it might be overwhelming in the starting, but later on I'll finally summarize this. So initially it starts with how you enter the source code input, right? So basically you have written the code base and you hit go build command, right? And finally the compiler reads your source code file, and the first step would be the Lexer phase. This is the phase. So it's the first step. Here what happens, every command, every sentence in your Go code is actually being broken down into smallest unit of meaning, which is token. So you can say, for example, if it's a hello world program, right? So you have package, main. So Go is actually breaking down in these keywords. Keywords could be identifiers, variable name, etc., function name, it could be operators, etc. And here at this stage, discarding of the white space and comments also happens. So I hope you are clear with this stage. So this is also called as scanner phase. So once the Lexer converts your code into tokens, it gets passed to the input to the parser. So parser has the input of the stream of tokens which were actually converted into the phase of Lexer, and it ultimately creates or constructs a tree-like structure, which is abstract syntax tree, AST, which is the output of the parser ultimately. So once parser gets involved, so it will get a stream of tokens, and then finally result output is a tree-like structure. Basically it's a grammatical structure of the code. So at this stage it also checks whether your code is actually aligning with the grammatical rules of your language or not. Language by here it means Golang. So it is actually checking if whether your code is structured properly in terms of grammatical issues or not. So once this phase is over, next phase is type checking and semantic analysis. In the semantic analysis, what happens is your code base gets your code base has the input of AST right now, and it gets into the semantic analysis phase, and finally it actually checks whether your code base, the tokens actually AST, is actually sticking adhere to the semantic rules of the language or not. So this is what it looks like, and here at this stage, type checking or type mismatching, constraints, scoping rules, all these things are being checked, and ultimately it ensures the operations are performed on the compatible types like type mismatch. So for example, it ensures that you are not using an integer as a function. So if you have used, the compiler will actually halt there, and it will actually showcase that you are using a wrong integer. And the next steps after the semantic analysis phase is the generation of the intermediate representation. So at this stage what happens is you have already checked the semantic analysis, syntax analysis, and so what happens, it translates the AST into the series of instruction set which are actually being passed to the next phases. And it is independent of the machine target, like your target machine's architecture, so it doesn't care about much, but it acts as a middle ground where a lot of optimizations can actually happen. So you might be aware that Go compiler is quite fast. So how does so the optimization is very, very much important here at this stage, and this is why this stage is very much important, because it helps in optimization. So once this is done, and this is a lower level representation of your code, but it is not actually machine level code, but it is quite close to the high level, it is close to your machine, but not that like high level code. And as I was talking about optimization, so intermediate representation is the phase which helps the compiler in optimizing the code base. So there are a lot of techniques through which we can optimize the code. One of the methods is SSA, that is static single assignment, where basically each variable is assigned just once. So this ensures that your code is more optimized and a lot of dependency is deprecated here, like it's avoided. And next is it generates the machine code. So what happens in this phase, you have already achieved all the phases, syntax analysis, semantic analysis, and then finally we come to the machine code generation part, where machine codes actually get generated, which is basically what your processor will understand, right? So binary instruction that processor can execute, and it actually maps the series of all the set of instruction set to the machine code instruction set, and it takes in account to the specifics of your target machine's architecture. So previously it wasn't the case like in intermediate representation, but it is the case here. So this ensures that your code is specifically running on your target machine architecture, like it considers like types or numbers of registers, etc. And next is linking machine code with the library. So this is the final step in the code compilation phase. And here what happens, linking actually resolves the differences to the different type of files or different type of variables which are present in the different files or libraries. So ultimately linking will help in achieving everything will be there in your single binary, and hence executable will be actually created, and that could be actually processed or taken into considered by your processor, and so that your CPU can execute that executable, and hence it will run the program. So if you see this, if this is the summary of your compilation, so it starts with a source code input, but actually Go build tool is doing all these phases, and it goes through all these phases till the executable is ready, and this happens in within a second, right? Sometimes within milliseconds, or it depends on the code size. I wanted to give you a slightly overview of how it looks in the Golang, but since we are time constrained, so I'll just give you a slight overview. So you can just see a lot of things are already built in the compiler, like log statements, panic visualization of your logs, etc. If you run these commands, I really wanted to show these things hands-on, but since it was a 15-minute talk, so I wanted to avoid it. So if you run these commands, if you are curious enough to go back and try these commands, you will see a lot of things like how is SSA file, HTML file is generated for function foo. You can see print assembly, you can see the compiler phases timing through these commands. You can get the talk slides later after the words. And a lot of other helpful tools are also, I've tried using it, and one of them is benchmark, and compile bench, so it benchmarks the compilation phase for the compiler speed basically, and bench state. So you can go through these tools which would be helpful in the whole compilation, if you want to deep dive into the compiler, Go compiler. And I try to get into the details of the Go compiler through these, like source code is the actual source for everything if you really want to check. So if you want to check how lexer parsing is happening, there are a lot of switch cases which are happening. It checks is equal to, everything is in the source code. So I have listed the directories where you can actually find where AST is getting constructed or lexer parsing is happening. So you can go to the directories directly. And these are the slides resources which when I was reading about Go compiler, I found it very much helpful, and you can go through them whenever you get a chance. And that's all from my end, and thank you so much for attending on a Saturday evening. I hope you enjoyed this talk, and I hope it ignites some curiosity in you so that you can try those commands whenever you get a chance to try them. Yeah, thank you so much everyone for attending my talk.
Thank you very much. We actually have a little time. Is there any question for the speaker? No? Okay, if not, also feel free to engage. Oh, okay.
Where would Go be faster than, let's just say, like okay, I think the fastest JIT compiled one would be Lua, like some version of Lua JIT. Is there like a optimal kind of use case for Go in terms of getting speed, but you're still kind of got a garbage collected kind of fast kind of development?
Can you rephrase? Like, I could understand a bit, but not complete question.
Where would you say is the best use case for Go in terms of where it kind of takes advantage most of its speed without there'll be some kind of numerical things where it probably doesn't take full. It's not designed for that, so it doesn't benefit, or it's not designed to there'll be some kind of there'll be a C application where it needs the speed, but where would you say Go's niche?
Okay, understood. Thanks for asking this question. So basically what happens, for example, C, you talked about C, right? C doesn't have garbage collection. So in Go, it's already being inbuilt. So it already helps a lot of things which a newbie doesn't want to spend a lot of time on, right? So if you work on Rust, let's say, or C, you will need to first work on those parts, write those things from scratch, which I don't need to write if I am using Go. So for example, you might have heard about TypeScript thing. They have recently written everything in Golang recently, 2, 3, 4 days back, and they choose Go because of the same reason. A lot of things were actually helping them in similar scenarios. And if you kind of ask me about the use case, so Go is really popularly known for its concurrency, right? So are places where a lot of concurrent scenarios are happening. For example, streaming is happening. Prime Video is there. You are watching something, Netflix. So there, Go concurrently, you are using a lot of concurrency principles. So their Go will be very much helpful. And if you have to talk about with Java, so Java, if you compare, so sometimes it might be similar to what Java is providing, the same efficiency, but it really depends on your code, and you need to actually benchmark them. So that's what also TypeScript did recently, and they have written a whole blog about why they chose Golang over Rust, because they benchmarked the things and it worked for their own purpose. Yeah, I think I was able to answer your question. Yeah, thanks.
Okay, thanks very much. So this will end the sessions for this room. And everyone is invited, of course, to the closing ceremony. It will happen in the main hall. Yeah, so please feel free to make your way there. Or of course, if you need to engage with Ms. Tosna, please feel free also. Yeah, so I'll see you around in the main hall. Right?
Thank you, everyone. Thank you.
Thank you.